Hello everybody and welcome to another YouTube video. So in today's video, I'm going to show you why random numbers are not so random. What I mean by that is that random numbers in most computer programming languages are actually generated deterministically. That means that you can predict exactly what numbers will be generated randomly from whatever generates the random number, and you can actually control it as well. Now, I'm going to show you a few examples here in Python, but you can likely try this in other programming languages as well, and you'll see that the sequence you're getting is not quite random. Now, there is a lot of techniques used to make it seem random, but really what's actually used behind the hood of Python and other languages when generating random numbers is a pseudo-random number generator. So that means it's not a real random number generator, and it's not truly random. All right, so with that said, let's dive into the video. But first, I need to talk to you about something that's not random, which is the sponsor of this video. Before we get started, I need to thank the sponsor of this video, which is AlgoExpert. AlgoExpert is the best platform to use when preparing for your software engineering coding interviews and has the highest quality coding interview practice questions. With 160 practice questions, detailed solutions in 9 of the most popular programming languages, a feature-packed browser-based coding environment, extensive test suites, and conceptual overviews and code walkthroughs for each and every problem, AlgoExpert is the best resource to use to ace your coding interviews. AlgoExpert also has a data structures crash course, coding interview assessments, and a mock interviews feature. I can highly recommend AlgoExpert as a former customer myself and now an official instructor on the platform. Get started using AlgoExpert today by clicking the link in the description and using the code TechWithTim for a discount on the platform. All right, so let's go ahead and dive in. Now, first thing I want to mention here is that if you want to read more about this, I will leave a link in the description to the random module from Python documentation. So you can actually see it says generate pseudo-random numbers. The term pseudo tells you these are not truly random numbers. And well, you can go through here, and this pretty much explains what I'm going to recap here in this video. Anyways, let's go back to this screen and let me show you what I mean by being able to generate the same sequence of random numbers and why the numbers are not quite random. So I'm in Python, so I'm going to import the random module. This has a bunch of functions allowing you to generate distributions, random numbers, random choices of elements, all kinds of stuff like that. Regardless, what I will do is say for underscore in range, and then I'm going to go with 10, and I'm just going to print out random dot rand range, and we'll go with 0 to 10. So this will generate a random number in the range of 0 to 10, but it won't give us 10. So it'll go 0 to 9, 10 is kind of the upper bound, which is not included. Anyways, let's just run this. And notice here, this is the sequence that we get. So I'm going to copy this sequence, and I'm going to run this script one more time and just show you that we don't get the same sequence again, right? So this sequence clearly does not match this sequence. And so at first glance, it seems like, okay, yeah, it is actually giving me a random number. However, I'm going to show you that I can make it so it gives me the exact same sequence. And the way I'm going to do that is by using this method called seed. So I'm going to say random.seed, and I'm going to pass a seed of 1. Now, some of you may already know what's going to happen here, but let's clear this out and let's run this. So this is the sequence that we get of 10 numbers, okay? I'm going to put it inside of quotation marks like this, and now I'm going to run it again. Now notice when I run it again, I get the exact same sequence. Now I'm not lying to you, I actually am rerunning the code. You can see that it's flashing, and I'm rerunning the code a bunch of times, and every single time I rerun it, I get the exact same sequence. Why is that? Well, the reason why I'm getting the same sequence is because I have the same seed. So you can actually control the random sequence that you get based on a seed. And the reason why that's the case is the seed is actually the starting value of generating random numbers. And the way that a pseudo-random number generator works is it starts at a specific value and performs deterministic changes to that value to give you some random value. And so whenever you're starting at the same seed, you always get the exact same random sequence. Now, this might actually sound really familiar, especially if you've ever played the game Minecraft. A lot of you have probably played Minecraft and you've seen that you can import or give a seed, and every time you use the same seed, you get the exact same map. And this works the exact same way. You give a seed, the seed is what generates the actual random sequence, really. It's kind of the starting point of it. And so if you put in the same seed somewhere else, you get the exact same map. Same thing here when we're generating random numbers in Python. Now let's just do one more example. Let me change the seed to 2. Now notice when I change it to 2, we get an entirely different sequence. But if I keep running this, I get the exact same sequence. So how does the computer actually generate a random number then? What does it use for this seed? If it can't generate something truly random, how does it pick something random for the seed? Well, the truth is, what's actually used for the seed by default is the system time. So whatever the current time is when you run the code is what's passed to this seed so that it's always different. The time is always different. But again, if you ran the code at the exact same system time, like to the exact same millisecond, you would get the exact same random sequence. All right, so now that we've looked at that, let's actually look at an example where we use the system time as a random seed. Now, this will kind of simulate what goes on behind the scenes, just so you can get an idea of what the random module actually does when it's giving you random numbers. So let's do this. Let's import time. Now, to get the system time in Python, you do time.time. Now, this doesn't give you like the date time. This gives you, I believe, the number of seconds past a specific date. So there's some date in which they like just picked arbitrarily, I guess, to do this from, but it's something like the number of seconds past like March 2nd on 1979. I'm completely making up that number or that date there, but it's the number of seconds past a specific date. So if I print this out and I go print time.time like this, you'll see that we get this, right? So just like a huge number. It's not telling me, it's January or February, whatever the month is, it's just giving me a number. Anyways, if I use time.time, I can put it like this. Now, every single time I run the code, let's just get rid of this here, I'm going to get a different sequence. So I get a different sequence because the seed is different and the time is constantly changing. So that's the way that Python actually does this. If you don't manually set the seed of the random generator, then it just uses the time. And obviously, we don't need to set this. If we just do this, right, it continues using the time. Perfect. So that's what happens when you use the system time. So now that we've talked about this, I'm just going to take a minute to discuss how do you actually generate something that's truly random? Because in a lot of cases, this is no good. Using a pseudo-random number generator can actually lead to a lot of security issues. And this is really important, especially if you're talking about something like cryptography, which relies on the fact that random numbers are not guessable. They're not predictable. Now, in this instance, it is completely predictable. And so if you know the starting point of the sequence, you're able to generate the random sequence. You can do the entire thing to infinity as long as you know the starting point. So when you're actually trying to generate something random, you need to pick some external source from outside of the computer to use as your random seed or to use to generate randomness. So an example of this, which seems really extreme, is actually radioactive decay. So in a lot of instances, when you're trying to generate a super random number, a real random number, you actually will monitor an atom and check for the radioactive decay of that atom. And that is something that is random in the universe. You can't predict when the decay is going to be. You can predict it to, a minute or to some level of precision, but you don't know exactly when it's going to occur. So a lot of computer systems that need to generate truly random numbers will observe something random in the universe, like an atom, and look for decay in that atom. Or more naively, they'll use something like a mouse. So as my mouse is moving around the screen, this is a completely random pattern. You can't predict how I'm moving the mouse. And so that's something you could use to generate randomness as well. Or like the sequence in which I hit keys on the keyboard or the timing for that. All kinds of things like that can be used to generate randomness and as a seed. Now, I'm no expert on this topic. I'm just giving you, the little bit of knowledge I have from reading about this for a few days. But I thought this was interesting, and I figured I would share it with you in case any of you find it interesting as well. With that said, if you enjoyed the video, make sure to leave a like, subscribe to the channel, and I will see you in another one.